Hello, Algebra 2 students. In this section, we're going to be talking about graphing square root and cube root functions. And in order to do that, it's going to be helpful to graph the parent graphs for each of these functions. All right, so what that means is we're basically graphing like the most simple form of the graph, and all the graphs that we will do after this will be some sort of transformation of this original graph. All right, so we'll start with the square root function, f of x equals the square root of x. All right, and this graph, the shape of it is a half parabola. I think I spelled that wrong. Yeah, parabola. Okay, and it has, instead of a vertex, this has what we're going to call a starting point. Okay, and that'll make sense when we actually graph this. So just like we use XY tables to graph our other function, we're going to use an XY table here. Okay, so our values for x and our values for y. All right, and we want to choose values of x that are in our domain, okay, because it's a square root. We can actually answer this question down here right away. Okay, square root, our domain is restricted to only 0 or positive values for x. So we can say our domain is x is greater than or equal to 0. Okay, and because we're taking the square root, it's going to be helpful to choose x values that are perfect squares when we're filling in our xy table. Okay, so like 0, 1, and 4 are all perfect squares, so these will be easy number to use when we're graphing. Like if we plug in 0 for x, our y value is 0. Okay, if we plug in x or plug in 1 for x, we're just taking the square root of 1, which is 1, and then the square root of 4 is 2. Okay, so these 3 points will give us an idea of what our graph's going to look like. All right, so we start at 0, 0, 1, 1, and 4, 2. So we don't really have a vertex, but we do have what we're going to call a starting point, which is going to be 0, 0 in this case. And we start here and we move out to the right. Okay, so we already talked about domain, and then the range is all the values we get in return when we plug in a number for x. Okay, so the only values of x we can plug in are positive or 0, and in return, the only values we can get for y are positive or 0. So our range is also y, or is also greater than or equal to 0, but it's y instead of x. All right, let's take a look at the cube root function. Okay, and then the shape of this is kind of a sideways snake, we'll say. A sideways snake, or almost like a really like stretched out S. Okay, and instead of a vertex, this has what we're going to call a heart in the middle. It has a heart. Okay, and that'll make more sense when we actually graph this function. So to graph it, we're going to use an XY table. All right, and since we're taking the cubed root, the values of x we can plug in can either be positive or negative, and it's going to be helpful to choose values of x that are already perfect cubes, because then we'll get nice whole number ordered pairs when we actually go to graph. So I'm going to choose 8, 1, 0, -1, and -8. Okay, because we're taking the cubed root, our numbers can be negative, and I chose all perfect cubes. Okay, so the cubed root of 2, if we plug in x for 8 in our function, we'll get the cubed root of 8, which is 2. Okay, we do that here, we get 1, 0, -1, and -2. So I just plugged in each of those values for x into our function, okay, and then I evaluated it and got our y value. Okay, so let's plot these points. So I'm going to start with my heart, which is in the middle of the graph, which is going to be our origin, so 0, 0, and then I have 1, 1, and 8, 8, or 8, 2 is going to be off the graph a little bit. It's going to be about right here. And then we'll do the same thing on the other side. We have -1, -1, and -8, -2, which is about right here. All right, so if we fill in this graph, Okay, it kind of looks like a sideways snake or like a stretched out S. All right, and then our domain, okay, remember our domain is the values of x we can plug in. And because this is a cubed root, we can plug in positive, 0, or negative numbers. All right, and we have no restriction. So our domain is all reals. Okay, and the range is the numbers we get in return when we plug in those values for x. Okay, and we can get any positive number, any negative number, or 0. So our range is also all reals. Okay, so that means we can plug in any number for x and we can get any number in return for y. So now we're going to talk about the standard form of radical functions and kind of some important parts about them. Okay, so here we're given the standard form. All right, y equals a times the nth root of x minus h plus k. Okay, and a determines the height of the graph. And if that a is negative, okay, all that does is reflect the graph over the x-axis. So if we have a negative out in front, like a -1, it's going to reflect the graph over the x-axis. All right, h is going to move the graph right or left. Right or left. And just kind of a thing to be aware of, in our standard form, it's x minus h. So that means we have to take the opposite of h when we're moving our graph left to right. So if this, if what's under the radical is like x plus h, we're really going to be moving to the left. And if it's x minus h, we're going to be moving to the right. So it's kind of opposite of what you would normally think. And then h, or excuse me, k is going to move the graph up or down. And just remember that square roots have a starting point, all right, at hk. And cube roots have a heart, also at hk. Okay, so a starting point, we move out to the right, and a heart, we move in both directions, left and right. So we're going to look at a few examples. Okay, so we're going to be given a graph, and then we're going to be given its parent, and kind of describe the transformation that's going on there. So in this first one, we have g of x equals the square root of x minus 3 plus 5. Okay, so here we have a square root parent. So square root parent. And then what's the difference from the original graph? Okay, so in G, all right, H is 3 and K is 5. Okay, so that means the difference here is we're moving the graph right 3 units and up 5 units. Okay, so we're moving that starting point to the right 3 and up 5. So for the second example, we have g of x equals -2 times the cubed root of x minus 4. All right, so the parent here is the cubed root graph. So we can say parent is the cubed root. All right, and that's going to be a snake. Okay, kind of that sideways snake we talked about. And then the transformation that's going on here, the difference between g of x and f of x is going to be this minus 4 here. All right, so that means that in this problem, our k is -4. So that's the difference there. All right, so if k is -4, the transformation that's happening is we're moving down 4 units. All right, and then number 3, okay, we have g of x equals 5 times the square root of x minus 10 minus 3, and then f of x equals 5 times the square root of x. All right, so we have that square root parent, and then the difference between them is this minus 10, and minus 3. Okay, so remember that h is the opposite. So then h is positive 10 and k is negative 3. So what that means is we're moving right 10 units and down 3 units. So that's the difference between those two graphs, okay? Our starting point is going to be moved right 10 and down 3. All right, so let's spend some time practicing actually graphing a few functions here. All right, I'm sorry this looks kind of weird, but I'm going to need a little bit more room for this example because there's a few things I want to talk about. Okay, so I'm going to do some of my work off to the side here. All right, our function f of x equals 2 times the square root of x plus 3. Okay, our job is to graph that, and then we'll state the domain and range at the very end. Okay, the first thing you guys got to do when we're graphing a function like this is determine, is it a square root or a cubed root function? Okay, well, since f of x equals 2 times the square root of x, okay, it's a square root function. So I'm going to actually graph my parent function, which is going to be f of x equals the square root of x, okay? We did this on the first page, so I won't spend a ton of time on it, okay? But basically, our values for x are going to be 0, 1, and 4. We plug those values back into our function, and we get 0, 1, and 2 in return. Okay, so if I graph this parent function, I'm going to go here, 0, 0, 1, 1, and 4, 2. All right, and the next thing I want to do is I want to identify a, h, and k of my function that I'm going to try to graph in the end here. Okay, so we're going to look at this function here, and we're going to find a, h, and k. So for this function, a is 2. Okay, a is that number we're multiplying, or that number out in front of the square root. H is the number we're subtracting from x. Okay, so there's no number under that radical with x. So in this one, h is 0, and k is the number we're adding at the end. So we're adding 3. So now we're going to use the xy table of our parent function and these values for a, h, and k to generate a new xy table that we can use to graph the function that we want. All right, so I'm going to create a new xy table. All right, and then this xy table is going to be for the function we're actually trying to graph. So in our standard equation, h is the variable that's affecting how far to the left or right we have to move. Okay, and x is the variable that determines how far to the left or right we are. So in my new xy table, my new x is just going to be x plus h. All right, so let's do that quick. So I'm going to take these values here, and I'm going to add h, okay? And so since h is 0, we're going to do 0 plus 0, which is still 0. 1 plus 0 is 1, and 4 plus 0 is 4. So I took these values here, 0, 1, and 4, and I added h to each of them, okay? I added h to each of them. And then my new y, so remember that a affects the height, so how high it goes up vertically, and then k affects how far up or down we move. Okay, so both of those are affecting the vertical axis, which is y, so those are going to affect our new y. Okay, so y, our new y is going to be y times a plus k. So I'm going to take each of my values from my xy table in my parent function for y. I'm going to multiply it by a and then add 3. So 0 times 2 is 0, and 0 plus 3 is 3. 1 times 2 is 2. 2 times 3 is 5. And 2 times 2 is 4. 4 plus 3 is 7. So now I'm going to use this new xy table to graph the desired function, okay? So the first ordered pair is 0, 3. The next ordered pair is 1, 5. And the next ordered pair is 4, 7, which is going to be off our graph a little bit, but right about there. Okay, now let's talk about a few things we notice about this graph. Okay, so A affects the height. So you can kind of see that this is a little bit steeper, all right? It's a little bit taller of a graph. Okay, if it's like the side of a hill, it's like a bigger hill. Okay, H affects how far to the left or right we move, and we can see that each ordered pair is directly over the other one. Okay, so we moved 0 units left or right. So H is 0, we didn't move left or right at all. And K is 3, so we took our starting point here and we moved up 3. Right, so that's how these values are affecting the graph. Okay, and this process will get quicker with time. There's a few shortcuts we can make that'll make this really easy. Okay, so in number 2, our function is h of x equals x plus 1 quantity to the 1/2 power minus 2. Okay, 1/2 power is the same as a square root. So I'm just going to rewrite this. H of x equals the square root of x plus 1 minus 2. Before we actually try to graph this function, I want to first graph the parent function. Okay, our parent function is just y equals the square root of x, and we make an xy table. We get 0, 1, and 4, and then we get 0, 1, and 2. So the graph is going to look something like this. Okay, we should get used to this. We'll be graphing this a lot. All right, it's going to be really helpful when we're trying to graph the desired function. Okay, the next thing I'm going to do is I'm going to identify what A, H, and K are. Okay, A is the number out in front of the radical. Okay, we don't have a number written there, so that means A is 1. H is the number we're subtracting from x, okay? So it's really the opposite of what we have under there. So since we have plus 1, our h is going to be negative 1, and then k is the number we're adding or subtracting, or we're adding at the end there. So since it's negative 2, k equals negative 2. So we're going to make an xy table for our new function. All right, and I'm going to write h is equal to negative 1 over here, and a equals 1, and k equals negative 2 over here. So we're going to take each of our values in our xy table for our parent function for x, and we're going to add add h, okay? So since h is negative 1, we're really just subtracting 1. So I'm going to take each of my x values in that table, and I'm going to subtract 1. So 0 minus 1 is negative 1. 1 minus 1 is 0. 4 minus 1 is 3. And for my y values, I'm going to take each of my y's from my xy table and my parent function, multiply it by a, and then add k. All right, so our first value for y is 0. 0 times 1 is 0. And then 0 minus 2 is negative 2. My next value is 1. 1 times 1 is 1. 1 minus 2 is negative 1. Okay, and then my final y value is 2. 2 times 1 is 2. 2 minus 2 is 0. So now I'm going to use this new xy table to graph the original function, and so we can plot our points, negative 1, negative 2, 0, negative 1, and 3, 0. And then we can graph that line. Now we're done. So remember that h changes the graph, the horizontal, okay, and then k changes the vertical. So this means we're moving to the left 1 and then down 2. All right, notice how each of these points is moving to the left 1 and down 2. Left 1 and down 2. Left 1 and down 2. Okay, so really all we're doing is we're taking each point and shifting it to the left and then moving it down 2 units. Okay, we're going to move on to number 3. This will be the last example of the notes. Okay, so identify what our parent function is. Since we're taking the cubed root of something, our parent function is going to be y equals the cubed root of x. Okay, and we graph this on the first page of the notes, so I'm not going to take a ton of time doing this. For the xy table here is going to be negative 8, negative 2, or not negative 2, negative 1, 0, 1, and 8. And then our y values will be negative 2, negative 1, 0, 1, and 2. So this graph is going to look like this. Okay, kind of that sideways snake. I know we didn't graph -8, -2, and 8, 2, but those just aren't on our graph, but that's okay. Okay, the next thing I want to do is identify my A, H, and K. So A is the number out in front of the radical, so that's -1. H is the opposite of the number under the radical. Okay, so right now we have a +1, so H is -1, and K is the number to the right of the radical that we're adding, and we're not adding anything, so K is 0. So for our new XY table, we're going to take the values of the parent XY table, and we're going to add X and H, and then take our Y, multiply it by A, and then add K. All right, so -8 plus H is -8 minus 1, which is -9. Okay, and then we have -2, -1, 0, and 7. Okay, so I took each of my values for X and I added H. Since H is -1, I really just subtracted 1 from each of these. Okay, and then for my Y, I'm going to multiply each of these values by A and then add K. So since K is 0, I'm really just multiplying everything by -1. So I'm just going to flip the signs of everything basically. So it'll be 2, 1, 0, -2, or -1, and -2. So now I'm just going to plot each of these ordered pairs and we can make our graph. Okay, so -9, -2 isn't going to be on our graph, so I'll skip that one. -2, 1 will be right here. -1, 0, and 0, -1, and then 7, -2. Okay, that'll be like right there. So I guess we can include that one. So our graph is going to look something like that. Okay, so you can see that because A was -1, we have that reflection over the x-axis, and because H is -1, we moved our entire graph 1 unit to the left.